relational algebra. So relational algebra is a procedural query language and it consists of six basic operators which are select, project, union, set difference, Cartesian product and rename. And in this the operators take one or two relations as inputs and produce a new relation as a result. Among these select, project and rename, these are unary operations, and union, set, difference, Cartesian product, these are the binary operations. So we will see each operators in detail. So first upon select operation. So notation used for select operation is sigma, predicate p and the relation r. P is called the selection predicate and this select operation is defined as tuple t such that tuple belongs to R and the predicate T, where P is a formula in propositional calculus consisting of terms connected by and, or and not operators, and each term consists of attribute, operator, attribute or attribute, operator, constant. We will see one example about this. For that we are considering a schema for banking example. So here number of schemas available for banking: branch, customer, account, loan, depositor, borrower. So we will see one example. Select those tuples of the loan relation where the branch name is query. So we are selecting a tuple from loan relation and in that we are checking branch name is query. So we are selecting this loan relation and the branch name. So when we select, so how we write that? Here the solution is sigma branch name is equal to query and here the relation loan. We will see second example. Find tuples in which amount lent is more than $1200. So again we are taking relation loan and in that we are checking the amount of loan is greater than 1200. So we are selecting a loan amount which is greater than 1200 and here the relation R, loan. In this way we are using select operation. So we will see in more general example of select operation. See here relation R is given which consists of A, B, C, D 4 attributes and the tuples for that. See here we are selecting A is equal to B and D is greater than 5 from relation R. So when we are checking the condition A is equal to B. So here the value of A is equal to alpha, value of B is equal to alpha, it is true, and the value of D is greater than 5 which is 7. So it prints that whole tuple. Now second one, alpha beta false, beta beta true, and then the value of D is less than 5, it is false. So we are not selecting that. Then the fourth one is beta beta and it is true and the value of D is greater than 5 which is 10. So it prints that. So in this way that whole tuple is printed by that select operation. Next operation is project operation. For particular attribute selection we are using this project operation. And see here the notation project. For project we are using pi symbol which is Greek letter and the attributes and from relation R. The result is defined as the relation of k columns obtained by erasing the columns that are not listed, and when the duplicate rows comes, so we remove that duplicate rows, we are select only one row. So here the example, we are taking same schema for banking database system. So to example is to eliminate the branch name attribute of account. So we are selecting account relation or the schema account number, branch name, balance. So we have eliminate this branch name, means we are selecting only account number and balance. So how we write it? Looks like this: project account number comma balance from relation R, that is account. So in general example, relation R consists of ABC attributes and tuples. So we are selecting only columns A and C. So we mention here A and C and the relation name. So it consists of this number of tuples, but here some common tuples comes, alpha 1 and alpha 1. So that eliminates that alpha 1 and writes only once, alpha 1, beta 1, beta 1. This is the result. The next operation is union operation. The notation is R union S and defined as tuple T such that tuple belongs to R or tuple belongs to S. And here we found some rules that relation R and S must have the same arity, same number of attributes, which the meaning of same arity is same number of attributes, and then attribute domains must be compatible. That is, if in column the attribute is of type varchar, then in other relation that attribute also have a domain varchar, like that. Okay, we will see the example on that banking schema. Here the example is to find all customers with either an account or a loan. So for that we are selecting a relations depositor and borrower. So in that the customer name is common and account number is different, but we are selecting only a customer name from depositor and the customer name from borrower. The resultant relation consists of the customer name, okay, which is common in both, or which is only present in one relation, that is depositor, or which is present in other relation, that is borrower. Okay. So in this way we identify the union operation. We are using union operation. In general way, union operation is the R relation consists of AB attributes and tuples. S consists of AB attributes and rest of the tuples. So R union S is union of this. When the common rows comes, then it eliminates and select only one row. Okay, here that alpha 1 and alpha 2. So alpha 2 is common, alpha 2 is common. So that writes only once. Then beta 1, beta 3. The next operation is state difference operation. Its notation is R minus S and defined as tuple T, so that T belongs to R and T not belongs to S. Means we are selecting only tuples, that tuple belongs to only a one relation. So in this we are follow the same compatibility rules, that is R and S must have the same arity and attribute domains of R and S must be compatible. Okay. In general, the example is that R and S consist of AB, same attributes, and the domain is also same. Now R minus S, so whatever the common in that book, that eliminates, and those are not common, that the rows which are present at only one relation are taken. But also it depends on their positions. Here we are taking R minus S, so it gives this result. So here AB alpha 1, here we are checking alpha 1 is present or not, so not present, so alpha 1 is resultant relation. Alpha 2 present, so it eliminates that. Beta 1, so beta 1 is not present, so it takes that. And we are not considering the rows from the other relation, that is from S. The next